Hi everyone. So today we will cover count inversion of an array. I am Shreyans Jain. Our problem statement is given an integer array of size n. We need to find the inversion count in this array. So two array elements arri and arrj form an inversion if arri is greater than arrj and I is less than j. Let's understand what is inversion. So this is our main condition. So if we take this array and take 4 as the ith element and we take j which is greater than I, and if arri is greater than arrj, here you can see 4 is greater than 3. So this is an inversion pair. Similarly, if I take 2, here this I is greater than this j and this 4 is greater than 2. So this is a inversion. Okay, let's build the intuition. Let's start with a simple problem first. Suppose we are given two arrays which are sorted and we need to count the inversion pair hairs. I will vary here and j will vary in this array. If I take the first element which is 1 and if I compare it with 2, I can see 2 is greater than 1. And since this is a sorted array, every other element after 2 will also be greater than 1. So this is our answer. Like all these elements will be inversion pair with 1. Similarly, if I take 2, so for 2, if I check this 2, this is not greater than it. So we will jump to the next one. Now here the 3. Since 3 is greater than 2 and we have a sorted array, see all the elements after 3 will be part of the inversion pair with 2. So these two elements are our answer. So like what we did in earlier slides, can we use this in our problem? What if we break our array in two sorted subarrays and then count the inversion from them like we did earlier? So this reminds us of our merge sort where we perform operation on two sorted array and then we merge them. If you don't know how merge sort works, you can check my video in the description. Let's take this as an array, and if I break it into two parts, one part is this and another part is this. And what we used to do in merge sort is we apply the operation on the first half, get a sorted array, apply the operation on the second half, get the second sorted array, and then join them using some operations. So if we apply operation on this part, it will become sorted, and similarly for this part, this will also become sorted. From the recursion function, we will get the number of inversions at x for this part and y for this part. Now we will just join like we did earlier. So that will give us some z. So our answer would be x plus y plus z. So what we learned, we will use the algo similar to the merge sort. We will apply the recursion function which will give us the count for each part, and then at last we will count for joining this part. So this is similar to the merge sort. We will find the mid and then we will divide it into two half, get the answer for the left half, get the answer for the second half by using recursion, and then at last we will join them and our answer will be left plus right plus merge. So how we will merge is, it's similar to the how we used to do for merge sort. We make two array left and right and we start with inversion equals to 0. We start iterating over the array. If the left less than equals to right of I, we will just move to the next element because this is not the case of inversion. But if the left of I is greater than right of j, then it's the case for inversion. We will move to the next element but also increase our inversion by n1 minus I. How this term came is, all the elements after the ith element will be satisfying the condition. So all those elements will be length of that array minus ith element. So that will be n1 minus I. And so at last, like we used to do in merge sort, we just copy any remaining element of left into the our array, or similarly for the right, and we return the inversion. Thanks for watching. Hope you will like it. Don't forget to hit like and subscribe to view more content.